derived that yeah, once it has derived that PTK, it will enter into connected state. Okay, connected state. In that connected and authenticated, we can say in that way, connected and authenticated. Okay, now it will do the data transaction. Everything will happen here. But whenever there is no, for example, for a particular amount of time, there is no data transaction between host and device. There is no bus activity. In that case, what will happen means it will come out of this connect and it will go to reconnect state, right? Trust timeout. Whenever that trust timeout is happened, then it will come out of that connect and authenticated state and it will go to reconnect state. In that reconnect state, it will request the host to again reconnect. So because of this trust timeout, it was come out of this connect state, right? Now already the host may assign some address. So here we have two. Here we will have two branches. One is with the previous address, or again it will do that four-way handshake, and it will start with the default address. That default address is nothing but 0. So from here there are two branches. Again it may start with the scratch, or it will start with the previous address. There are two possibilities, right? So this is what
After a period of greater than trust timeout, it will directly switch over to the reconnect state, or
reconnect state.
it will enter into reconnect state.
It will
Rather than intimating host in that by staying in the same state.
it in the reconnect state only. Again it will send some request to the host. In that request it will tell that I already connected with you. Due to some trust timeout, I came out of that connect state. So you tell me whether I should start with the four-way handshake, or can I move directly to connected state again.
Okay.
Like that it will ask. Okay, if host is having the memory of this device, then definitely it will have its previous address. So if it is having that knowledge on this device, means it will ask this device to go to connect state. If it don't have that memory of that device, that means the host forgot its name, its address, previous address, then what it will do, it will ask this device to start from the scratch. Okay, now look at that last point. The host may choose to either allow the device to reconnect while retaining the device state, or it may process the request as a connect request, instructing the device to reset any remembered state. Okay, and the revocation. When we make provisions for creating secure relationship, we must also make provisions for deleting them. Revocation of a connection by either party can be accomplished by deleting the unique host ID from the device, or deleting the unique device ID from the host. The host can delete the context via framework commands. Are you getting what is this? Revocation means we are going to stop the communication between host and device. How we can do means either we can delete the unique host ID from the device side, or unique host ID from the unique device ID from the host side,
Or vice versa.
yeah, and vice versa. Okay, so this is all about connection, reconnection, invocation, all these things. In some this is one special case. In some cases, host will not wish to establish a permanent connections. At the time, a one-time connection is established where its connection context is delivered to the device to allow a connection to occur, but the connection context is not retained for future connections. Suppose consider one example. We are going to use one wireless USB mouse. Anyway, we are going to use that mouse only with that particular our home PC. Okay, we are not going to use that same mouse into another suppose your friend's PC. In that case, think about that point. What will happen? At that time, a one-time connection is established where a connection context is delivered to the device to allow a connection to occur, but the connection context is not written. For example, the same mouse you want to use in different locations. In that case, it no need to remember that connection context. Once that connection, one-time connection is established, it will delete that connection context, and we can use it the same device in another host range. This is what they are trying to say. The host can accomplish this by delivering a connection context to the device, then the revoking the connection context immediately after the four-way handshake is completed. The important thing here is when it is deleting that connection context, once the four-way handshake is over, immediately the host will delete that connection context.
Means every time we have to start from the scratch. Is it like that?
No. I told that example. Suppose you are bringing your mouse to my home. In that we want to establish a wireless USB connection. Okay. In that case, what will happen? Already in your house, you may use a permanent connection context. Okay. But right now we are going to establish a single one-time connection. In that case, what will happen? It no need to remember this connection context. This in the sense that you are in my home. My PC will going to deliver that connection context. You no need to remember. How it will happen means the host will automatically delete that connection context once that four-way handshake is over. Up to that four-way handshake, it will use that one. Once connection is established and during the four-way handshake, it will derive the pairwise temporal key, and the connection and the data transaction will happen. After that time, you no need to remember that connection context, right?
What after that? After that, it will work through PTK type of.
Right. That's it.
At that time, it will.
PTK is used for encryption and all, right? Diagnostic support, in the sense support for diagnostic equipment is important for the success of a new technology. Wireless USB recognizes this need and accommodates it by leaving the common trigger elements in a clear text in transmitted message. Only the data payload portion of the wireless USB transaction will be encrypted. Device notifications are authenticated only and contain no encrypted data. 3 suggestions of dealing with the encryption when using the diagnostic tools are: test in unauthenticated mode. This is simply diagnostic support what they are providing in this wireless. 3 points. First point, test in unauthenticated mode. How we can test in unauthenticated, or how we can do that diagnostic operation in unauthenticated statement. This mode supports a limited subset of framework requests and test modes that can be used to test basic operation. We know that if you are implementing any new device, we will have one normal mode operation and a test mode operation. This test mode operation is for compliance testing. For example, if the device is working or not, for that itself we will implement a special logic. Okay. So that is what they are trying to say here. And second point is make the connection key available to the diagnostic software. Diagnostic software will be there. We have to make aware of that. To aid in this, the specification defines the connection key value of 0 to be wireless USB diagnostic connection key. That connection key, we know that connection key. Okay, that connection key again 128-bit value. That value 0 is reserved for this diagnostic operation. The third point is provide a means of moving the current temporal keys from the host